And we back. So that's what we have with the last simulation. That's much better. So you can see that we have some noise in the beginning over here, closer to the ship. Then the first explosion. In this area we have the wave, the small wave around the ship, which is move up a little bit. And the second explosion with much bigger splashes. All right, bam. So that's looking good. You can see that not too many particles here on the surface, but the main reason why it's happened is because we look just with particles on the surface. You can see that it's like an empty inside because it should be filled with the compressed fluid surface. If you select particles and compressed fluid surface, you can see that it's looks very different. Now we fill our inside volume with some fluid. So it's volumetric. And you can see the waves here. This is our ship. You can see that we have the interaction with the ship. We have a collision with the water. Yeah, it's empty inside. So we can try to fill the ship with some volume. But to do this, we need to take our original geometry, fill all holes, make this geometry close, and then fill with the surface inside. And sometimes it can, create too many voxels, which I basically don't need. I don't care about liquid inside of this ship. So it's looking good. It's looking not bad. And you can see how it works the fell off from the ship. You can see at this distance. In this area, it's almost flat. So we can connect our flip tank, our flip pool, with the ocean geometry without any problem. We don't need to blur something or to create something else. So now what we need to do at this stage, before I create the water surface, I want to play with the secondary simulation, and the secondary sim is creating the white water. So the main thing with the liquid simulation, you need to keep in mind that yes, we created details on the water surface, but even with, let's go to the second splash, even with this amount of particles, unfortunately I can't see how many particles I have with the simulation, because I use the fluid compress, which will remove particle inside of the liquid, and we have just particles on the surface. But you can see that it's not a big amount of detail here. It's not a surface, it's a volume still. It's not a surface, it's particles plus volume. So in many cases, if you want to have many details on our simulation, we need to create secondary elements like splash, foam, bubbles, so on and so forth, because they add a detail. The best thing for our flip simulation is the speed. We can create 1,000 million particles in our simulation, and we still can do this on our PC using just 32 or 64 gigs RAM, and it's looking good. But if you want to have more details, you need to create splashes as particles, because those, some kind of waves, the liquid surface is not such detail. Even if I add more particles, even if I set like 0.05 for particle separation or more, it won't create the proper effect. Okay, so in many programs, actually in all programs I work with liquids, is Houdini, is RealFlow, and 3ds Max. The splash, foam, and bubbles sorry, creates from the secondary simulation. And that's how we can, separate our sims. If you want to have a nice water surface, you can create the flip simulation with settings you want. But if you want to have many, particles on the splashes, you can create a separate white water simulation and create as many particles as you want, or as your computer can calculate. So the advantage of this method is you can control each element of your simulation in any step, in any stage. So right now I create the water surface. That's what I want to do with our flip simulation. And now in the next step is create white water. Again, I will back to my particle fluid surface here, and I will create the mesh for rendering a little bit later. Before I do this, I want to create a little bit of white water. So the white water simulation creates a particle simulation without volumes, just a particle sim, but based on volumes we create inside of the flip simulation. So that's how it works. And if it's particle, we can use many different things we can create, we can use in particles. It's like pop forces, all right? Any other elements like a pop wrangle, we can control our particles using different forces, custom forces, forces inside of Houdini, noise, and all other stuff. We can use the attributes for controlling the particles, controlling the color, controlling the scale of particles, the p scale. All right. Also, we have a few methods in the output way. So how we can render those particles as particles or as the volumes. Okay, which I can choose, and I will show you a few examples how we can render those particles. All right, so what we need to do first, the first thing we need to do is create another geometry. So this is our flip simulation. Let's create a flip sim and colorize it a bit. Okay, let's do this flip sim. And let's go to geometry. I want to create the white water source. I type it white water, davi, and let's create a source. So the first thing I want to do, I want to take my flip cache. So I'm going to take this set a null object, and let's name it flip out. Make it dark, copy, get back to source, object, merge. Let's remove this guy from here, properties. That's going to be my flip cache, and paste the path to my flip. So in fact, now you can see that we have those strange boxes, and this is my compressed fluids, as we can see. And I can use this volume to create our white water. So the sourcing is very important because there is many different thresholds we can use for define the areas where I want to create our white water. So if you go to white water source, that's a node, has many different parameters and many different ways how we can control how many particles we have. And if I enable my white water source, by default we can see that there should be some volumetric stuff. It takes some time because it's getting the cache from the whole flip out and then create the source. Okay, so now you can see some kind of a density field. It's looking like a density, but just a simple volumetric which visualized like a fog. All right, and you can see that it's not taking the whole area of liquid and just select some areas. In this case, we have some curvature, acceleration, vorticity, so on and so forth. So you can see the white dots, white areas around my flip, which is I don't care. I am more interested in the areas here near the ship. All right. So there is many different tabs, and let's begin with the first one, and it's an emission. So an emission tab is pretty simple stuff, which can control the limit by depths. So what is the depth in this case? Well, you know what's the depth if we're talking about water, so how deep we go under the water, and then we can call the depth. So in this parameter, the depth can control which type of particles we can create. Let's type something. So let's say there is three main particle types in white water. It's the splashes. Where's my mouse? Okay, so splashes. It's the foam, and bubbles. So when we create white water, is basically generating the particles without any separation between splashes, foam, and bubbles. But we can separate them, well, I mean without any visual separation. But in fact, let's say we have the water surface. The particles exist outside of the water surface, okay? Above the water surface is our splashes. Okay, from water, if our water will hit something or some object will hit the water, we create the splashes. They move up from the water surface in the air. These are our splashes. the bubbles, the particles, which should be under the water. All right, and here we go, somewhere here, and the form is our particles which exist in the water surface. So it can be the same, simulation, and we have a bunch of particles, but depending on the depth, we can select which particle it can be a splash, form, a bubble. All right. So, and in this thing here in the depths, we know that if we have the depths bigger than 0, it means that our particles somewhere under, so not under, it's above the surface. It means that all particles which have a depth bigger than 0 will be splashes. All particles which have the depth equal 0, they are on the water surface, and all particles which have the depth less or negative values, right, they will be bubbles. So in this limit by depth, we mean that where we want to create the particles, and by default you can see that we create particles under the water and on the water surface. There is no positive values. We can't create particles above the surface, but we can change this. We can change like 0.3, and I want to create the bubbles. In my case, I won't see too many splashes or too many particles under the water, so we can reduce the limit by depth. Let me just okay, let's leave it 54. So let's take like minus, let's say like minus 0.2. So in this case, we will have just a small area above the water, under the water, and small area above the water. In this volume, in this area, we will produce some particles, some white water particles, minus 0.2 and 0.3. So the maximal half width, the VDBs, I don't change it, maybe 25 should be good, and the speed range. So the first threshold, the voxels where we create those splashes should have a speed and velocity, actually length of velocity, bigger than 2. Okay, so it's like a speed range between those values. Just volumes which have such a speed will produce white water. If your speed is lower than 2, you shouldn't create the white water. And this is the first limit, because like in real world, if we have a splashes, something should create this splash. If we have a static water without speed, without moving, sorry, there is no splashes. So if the water create the splashes, something should move this water with a bigger speed, or this water will hit something, all right, with a big speed, or some element will hit the water, and again this water will have some speed. That's where we create our particles. Okay, so it's the first threshold. Maybe we reduce the speed a little bit, maybe like 0.5. All right, and the maximum maybe like 3. So you can see that if you look at our help, all regions of the liquid that have a speed greater than the minimum are eligible to emit white water. All right, and moving above the maximum speed are considered fully emitting. Okay, so depending on the speed, it will control how many particles we create in this area. The less speed, let's say speed closer to 1.5, will produce less particles. In the areas where we speed have like 4 or more, we will produce the full amount of particles. How many particles we will produce, we will control this later. Also, we can make a remap speed. So if you want to create like even more particles around the area of 3, somewhere here, we can move this line here, or make it smaller. It's up to you, but in this case, I don't want to change it. And then we have 3 different type of some kind of thresholds, again, another thresholds, which can show us how many particles and what thresholds I can use for creating those particles. To better visualization, we can go to the last tab, visualization, and press source particles. So we can see that with the different colors, we can look at our particles and see which of those thresholds create particles depending on the values. So you can see that the red particles created by the curvature. If you go to curvature, those mean that basically we can look here. So augment emission rates with the curvature of the surface SDF, which can be an effective criteria for detecting the leading edges of breaking waves. So it's good for breaking waves. You can see that there's a lot of red particles here around our container because we have a curve there. We have like corners. So, and basically, yes, if our water, changing the angle, it shouldn't be some, some factors will create this angle. So this water is hit the surface, the ship surface, or the ship can move through the water and create those angle velocity. So there is the velocity angle, the maximum velocity angle, and also we have the curvature range. But in this case, I don't want to use the curvature. Okay, so now we can see that we have mainly green particles. And just a little bit, can we see something different? So the green particles is acceleration and the blue particles is vorticity. There's not too many vorticity. If we disable acceleration, can we see? Yeah, there is some vorticities. So again, if you create a vorticity attribute inside of our simulation, let's back to manual mode for a moment. I just want to remind you that inside of the flip solver, in the particle motion, we enable add vorticity attribute, as you remember. And this is very important because if we won't do this, we won't have the vorticity attribute in our cache. And that's how we can't use this vorticity attribute inside of the white water source because we don't have a vorticity. That's correct. So in this case, I want to, you can see that vorticity, it's like a swirling for our particles, create little swirls, and it looks how many vorticity in our liquid, in our volumes. So I want to reduce this vorticity a bit. So let's reduce the range from 20 to 10. Let's back to my auto update. I want to see how it's changing. Again, I don't care about those areas. I just look at here. All right, so now I can see more blue areas, more blue particles, and it's looking nice. Let's decrease also the maximum value like 20. So now when we decrease the range, it means that we create more particles in this range from 10 to 20. Okay, again, maybe without any kind of ramp, and let's enable the acceleration. So without acceleration, with acceleration, we can sometimes cut elements which we don't need to use or to see. And in this case, I want to increase the acceleration range from 40 to 60, because I just want to create a white water around the areas with a big acceleration. So the acceleration is emission rates with a magnitude of acceleration is effective at detecting areas where particles are rejoining existing part of the fluids, resulting in trapped air that causes white water. All right. So in this case, I will move this up a little bit, the minimum range for my liquids. And also what I want to do, I want to go to my volumes, and we have the voxel size. So the voxel size show me the quality of the volume created from the white water source. But also what I want to do, I want to cut those areas around the flipped tanker. I want to create white water just on this area. So to make it possible, I need to use some kind of mask. You can see that white water source has 3 inputs. The first one is our liquid simulation, which we connect over here from the flip cache. The next one is extra source points. So if you want to add some extra sourcing to our white water, you can do this. And also we have the emission mask, which is very important because sometimes we have a big, water tanks, big water simulation, but the foam and actually the white water we want to create just near the camera in the areas we can see with camera. I don't want to create the splashes somewhere, after the building we can see it. We need to have the water there because it's flowing from the corner, but I don't want to create particles there. So that's how I can control the volumes where I want to create my white water. And to do this, I can create the box, which is basically have the same proportion like we had from our here the sourcing with the flip source. We have the active zone, have this box. Let's enable that. Let's try to create the flip source, so it takes some time. Let's enable that. So, but this box should be much smaller, okay? Just around the ship. That's what I'm interested in. So let's go here to the source. Let's set a template for this box. It's pretty small. Let's make it, I don't know, 220, 20, oops, sorry, 20. Let's rotate it -20. I know this angle because I rotate my ship on this angle, -20. So maybe a little bit smaller, like 80. Okay, let's move it here. Let's look at from the camera. Let's look at this box. Let's copy this parameter and paste relative reference. So I mean that I want to divide it by 2. So it will be on the water surface, and maybe put it 2 meters under the water. All right. So, and let's make it -5 in this. Oh, come on, -5, -7. Okay, that's better. Yeah. All right, so now you can see that I cover all areas near the ship, and I'm not interested for those areas. So now if you want to use this geometry, if you go to our volumes, we have the mask here. If I enable mask, we should have some name. So we can say like a box 1, but it's not the name of the node, it's name of the volume, because if you create the volumes, the mask should be volumetric also. So we need to take this box and convert this into the volume using the VDB from polygon, let's say. VDB from polygons, we can create a surface, so that's our name of our mask. We can increase the voxel size because we don't care about the quality of this box. We need just a surface, and we need to fill the interior because maybe not such a big voxel band. This one, I don't want to shrink this too much. And let's connect this guy here at the mask and type the name you want. You can change this from the surface to any type you want. You can state the volume mask or something like this, just to have an understanding of this mask. What is the name of this mask? So, and you can see now those areas now was cut. All right, so if you look from our camera, it's looking very nice. So let me look the last time for my white water source. Okay, we have the voxel size, and I say that we can keep it 0.1 because you know, I want to have as many details as I want, maybe even less, but in this situation we can leave it 0.1, and we can turn off the source particle. So also we can, you know, create a water scale here, but it's just a visualizing. So it visualizes where is the source, and depending on which criteria we create our liquid, our white water sourcing. All right, but before we use this source for our white water solver, I want to add a little bit of noise on this source, because at some areas you can see that it's very flat here, so it will create, you know, like a flat surface with the foam or with the splashes, and it looks like a big sphere, the big white sphere, and it's not looking like the splashes of water. So what we can do is go to the attribute warp. So, sorry, I want to create the volume warp because I want to create the mask inside of the volume field. All right, we create the field, and this field called emit. If you go to white water, you can see that we create the emit field, which has 646,000 voxels. Not too many, so sometimes we can control and create even more voxels here. All right, let's call this emit noise. Go down inside. Let's open it in a full screen because I will create a few nodes, and then I want to control the noise, the size of the noise, and all other attributes. So let's use the anti-aliased noise with the 4D noise, and let's use the 4D input and 3D output, or no, let's use 1D output. Okay, so we need to create a position for vector, and as you remember, we already did this, the vector to vector 4. Let's take a position, let's take the time and connect it to position. So in fact we use time as the force value for our vector. And the another thing I want to do here is changing the our emit field. So I want to bind, type emit, and I don't need the volume output, and bind export, and type emit also. So between those two guys, I want to set a multiply, connect it over here and over here. And I can use the noise inside of this multiplication. So for the noise, I want to set, and let's go to the noise. I think that I need to get just a frequency, and basically that's it. I think the amplitude I will leave as it is by default. I set to 1, so we can increase a little bit of roughness to like 0.6 and play with the play with frequency. And I guess it's too much. Let's copy parameter, paste relative reference, paste relative reference. Let's say maybe to 2. So you can see a difference here and here. We remove too many elements. Too many. Say to 3. Not too much changing here. So let's apply the fit, because I get that we have many negative values or very small values, which with multiplication create a very big black hole here. So let's leave the output 0 to 1, and let's decrease the maximum value to 0.5. That will take all our values bigger than 0.5 and compare to 1. And let's get the anti-ALZ created in negative values. Let's take some negative values from here. Maybe even smaller, like here. That's better. That's better. Alright. And we can also create like a global multiplication. So let's say 1, call it multiplier. And we can control the amount of our noise. We'll say to 0.5, 0.75, let's say. All right, cool. And what I want to do is look in the amount of liquid under the water. Let's go to the front view. Let's reduce a little bit of source under the water. So what we can do else here? Let's remove this guy. We can take our vertical position. So let's set vector to float. Let's take a position from our here volume global. Let's set the fit range from the Y position, which will create for us position by the depth, and multiply our field over here. So now I can see that by default, because we have the values from 0 to 1, it's gonna cut all areas under the water, but I don't want to do this. The first thing, I want to set the inverse like 1 to 0, but I want to set the negative values here. So let's say -1 and -2. So what does it mean if we disable the multiplication? You can see this creating some kind of fading. The less areas closer to 2, let's say like 2, let's say 2, okay, that's good. And maybe 1.5, no, 1 could be fine, could also 1, 2, all right. So we cut some areas. With the smaller maximum value, we can, you know, put this area up, so minus 0.5 maybe, 0.75, something like this. Okay, so this is our source. Now we can use this source for creating actually our particles, but before we do this we need to save it. So let's go to File Cache and let's name it www source. Save this guy from 1 to 100, load from disk, and let's save this guy into the flip. You can just flip. Oh, come on. Okay, that's the wrong language. Flip $S, $F, BGOSC, 100, good. So we're gonna save this guy and we'll be back soon. Yeah, let's set an null object just to visualize that this is our source out. Cool. Now let's save it.